Soil composition and properties 4.3. Objective describes similarities and differences between properties of different soil types. Holding water capacity, amount of water of soil can hold. Then water retention contributes to land and productivity, fertility of soils. Particle size and composition of each soil horizon affects porosity, permeability, and fertility of soil. Then methods to test, it would be biology, physics, and chemical properties of soil that adds to variety of irrigation and fertilizer. Then we have soil texture triangle. It's a diagram that allows the identification and comparison of soil types based on their percentage of sand, clay, and slate. We have soil particle size and texture porosity. Geologic rock portion of soil made up of 3 particles. And we have sand, slate, and clay. Then we have soil texture, the percentage of sand, slate, and clay on the soil. Because sand is bigger and has bigger pores, which are empty spaces, this allows air and water to enter the soil and to moisture it. Clay has small pores, and it's 3 times harder for air and water to enter clay. So it has low porosity. Porosity is the amount of pore space in soil has. More sand in soil, more porosity, and easier for water and soil for the water to enter the soil. And more clay in soil is less porosity, which is harder for water to enter the soil. Soil texture chart. Here we have our triangle, and we classify the soil textures by the percentage of clay, slate, and sand, and it makes sure it adds up to 100 when we calculate it. So the directions to calculate the percentage of clay and slate and sand, we have to start with the percentage of sand and move to the part of sand where the sand and slate meets, and then go to the clay. So there are the 3 directions. Then we have 4.3, which is the porosity and permeability of H2O, holding capacity of water capacity, holding water capacity. So we have porosity, pore space within soil, more sand, more porous, more permeability. And permeability, which is how easy water drains through soil. More porosity, more porous equals more permeability. The ideals, then we have the ideal state for plants to balance the permeability with sand and water holding capacity with clay. And then we move on to H2O holding capacity, water holding capacity, how well water is retained by soil. So porous, permeable equals lower water holding capacity. Then we move on to soil fertility, ability of soil to support plant growth. We can see in the diagram that the sand is more expanded and it has more space for the water to come in. Then we have slate, which doesn't have a lot of space. It's in between no space and space. And then we have clay, which has no space for water to come in. Then we can see that too acidic soil equals less nutrients. Tilling, which is removing roots, equals soil loses its nutrients. And then we have to calculate the percentage of soil of clay, slate, and sand in the soil. And then we have the FRQ. The FRQ says Identify and describe a test to be conducted for a soil sample. And for this first one, we have a pH test can be conducted for a soil sample to measure soil acidity or alkalinity. 7.0 means neutral, and above 7.0 means alkaline, and below 7.0 means acidic. Then we have in the FRQ, explain how results of test allows you to give advice for a farmer trying to grow their crops in soil. You can conduct, and the result for this is you can conduct a soil pH test in order to determine what plants fit best in the best area to grow your crops and increase your production. So, which means that each plant has a specific pH, and the farmers can determine which area where to put the plants, and then they can grow more crops, and that's it.